Hey, this is Hacker and Madison Fichtner for Networks 466, and today I'll be demonstrating Project 3, starting with Part 1. So in Part 1, we had to generate a message that was at least 80 characters long, and then we broke it up into two separate packets. And we did this in the UDT send method in Network 1. If a packet was greater than 50, the length, then we separated it into two pieces. It wasn't too bad. I'll show you the output here. Cool, and then for Part 2, we had to send packets over different MTU sizes. Like for instance, when the link of router A and route host 2 is 30 MTU versus the 50 that was set in other parts. And we segmented the packets by adding a flag in the network class. And there's a flag to show that there are more packets on the way, and then there's also a flag to show that this is the last packet being sent. And that way the host knows when to concatenate all the packets together. And I'll show you that flag up in network packet that we added. And then we also revamped the UDT send method in host to calculate the total number of packets that we had to send here. And then over a for loop, we have all the packets being sent, with the last packet, of course, having that set flag of 2 being the last packet. And then we also have a reconstruct method that concatenates all the data back together. Let me run that real quick. Cool, and then we have this packet is probably a bit too long, but I'm going to send it anyways. You can see it's broken up to the MTU size of 50. And then we also have the packet being shortened again for the MTU size of 30. And then at the end we have host 2 successfully reconstructing the packet. This packet is probably a bit too long, but I'm going to send it anyways. And then for part 3, we also added a source address to packets, along with the flag to make the dictionary lookup simpler. And then we also added multiple interfaces to routers A, B, C, and D when we create the routers in simulation. And then when we create them, we also pass in a dictionary here. And this dictionary contains the original address and then is nested to have the router names with the correct interface that is supposed to be sent out on. So that way when routers get a packet, they reference the packet's original address and then the router's name itself, and then it will show you which interface to forward out on. And I'll run that real quick. So we have the original message of I will build a great wall on our southern border, being sent from host 1 to host 3, and on host 2 we have sometimes I'll start a sentence and I don't even know where it's going. I just hope I find it along the way, being sent from host 2 to host 4. And then down here for host 3 we have host 3 successfully reconstructing the packet of the original message about the border wall, and host 4 successfully reconstructing the packet about forgetting a sentence. And that's due to the routers looking up interfaces through the dictionary, which I'll show you real quick. Through this method, our dictionary method of the nested dictionary.